This lesson is on parallel lines cut by a transversal. We're going to talk about parallel lines, perpendicular lines, what happens when transversals meet parallel lines, and finally the relationship between the angles formed when we cut a set of parallel lines with a transversal. First, let's talk about parallel lines. Parallel lines are lines that do not intersect. Here's an illustration of two parallel lines. There are two others. And the notation we use is right here with the parallel sign. So we'd read this as line L is parallel to line M, or line AB is parallel to line CD. Here are some examples of parallel lines. Hardwood floors are set up in parallel lines of strips of wood. The parking slots in a parking lot, those lines are parallel. Parallel parking is called parallel parking because all the cars are facing the same way, parallel. And the streets Magnolia Avenue and Hester Avenue on this map here are parallel. Perpendicular lines are lines that intersect to form a right angle. There's an example of it, and there's the notation we use. Line M is perpendicular to line N. And whenever we have two lines that are perpendicular, four right angles are formed. Here's some examples of perpendicular lines. Railroad tracks, the tracks and the cross beams make perpendicular lines. Window panes make sets of perpendicular lines. Of course, there are parallel lines there as well, but the ones that go up and down and the ones that go left to right make perpendicular lines. And the streets Magnolia Avenue and the Alameda on this map are, for example, perpendicular. Now let's talk about what a transversal is. A transversal is a line that intersects two parallel lines at different points. So, for example, line T is a transversal because it crosses those two parallel lines. It's two parallel lines, and there's the line that crosses them as a transversal. Whenever we take two parallel lines and cross them with a transversal, 8 angles are formed. There's an example, and we're counting there are the 8 angles. And various pairs of these angles have named relationships, and we'll talk about those in a minute. So the first example is vertical angles, two angles that are opposite of each other. So in this illustration, angles 1 and 4 are vertical. Angles 2 and 3 are vertical, and therefore they are congruent. They have the same measure. Angles 5 and 8 are vertical. Therefore, they have the same measure. They are congruent. And angles 6 and 7 are congruent because they're vertical angles. They have the same measure. So we can use this fact to solve problems. So in this example, the purple angle there is 125, and the blue angle is 55 because they are vertical to the measured angles. Corresponding angles are two angles that occupy corresponding positions. So, for example, angles 1 and 5 are corresponding because they both are in the top left. Angles 2 and 6 are corresponding because they are in the top right. And corresponding angles are congruent, so angle 2 and angle 6 are congruent. That is, they have the same measure. Angle 3 and angle 7 are also congruent because they're corresponding. They occupy the same position, in this case, the bottom left. And finally, angles 4 and 8 are congruent because they're also in corresponding positions, in this case, the bottom right. And again, we can use this information to help us solve problems. So to find the angle right here, I know that it is 145 because it is corresponding to the 145 degree angle above. They're both in the upper left. There are other angle relationships that are named for where the angles are located. So for example, they're same side versus alternate side, and interior versus exterior. Same side angles are all on the same side. So for example, those and these, 2, 4, 6, and 8, are all on the same side. Alternate side angles are on opposite sides of the transversal. So for example, 2 and 5 are alternate sides, and 3 and 8 are alternate sides. And there are lots more examples. Those are the only ones I'm going to talk about now, though. Then we have interior angles, which are in between the two parallel lines. So in this case, angles 3, 4, 5, and 6. And finally, exterior angles are outside the parallel lines. So in this case, angles 1, 2, 7, and 8. Alternate interior angles are two angles that lie between parallel lines on opposite sides of the transversal. They're interior, so 3, 4, 5, and 6 are interior angles, and they're on opposite sides of the transversal. So for example, 3 and 6 are alternate interior angles, and 4 and 5 are alternate interior angles. And alternate interior angles are congruent. So angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. And again, we can use this to help us solve problems. If we're trying to find the measure of the missing angle, we know it's 82 because they are alternate interior angles. Alternate exterior angles are two angles that lie outside the parallel lines on opposite sides of the transversal. So outside, those are the alternate interior angles. Get rid of the others. And they lie on opposite sides of the transversal. So for example, 2 and 7, or 1 and 8. And alternate exterior angles are also congruent. So angle 2 is congruent to angle 7, and angle 1 is congruent to angle 8. We can use this to help us solve problems to find the measure of this missing angle because they're alternate exterior angles because it's an alternate exterior angle to 120. It's 120. So far we've talked about several types of angle relationships, and they're all congruent. Those are vertical angles. Those are angles that are opposite. Vertical angles are angles that are opposite from each other. Congruent angles, angles that are in the same relative place, alternate interior, and alternate exterior. Now we'll talk about other possible types of relationships, the ones that are supplementary. That is, they add up to 180. And those are going to be a linear pair, same side interior, and same side exterior. Let's go through and show some examples. So, two angles that form a line are a linear pair, and they add up to 180 degrees. So, for example, 1 and 2 going across, or 6 and 8 going up and down. And in fact, there are 8 pairs of linear pairs here, and the sum of all of these linear pairs, like all linear pairs, adds up to 180. So, if we want to find the measures of the missing angles here, this first one, since I know that 180 minus 72 is 108. This first one is 108 because it forms a linear pair. And the second one is also 108 because it forms a linear pair. Same side interior angles are two angles that lie between parallel lines because they're interior and they're on the same side of the transversal. So they're on the interior and they lie on the same side of the transversal. So for example, 3 and 5 and 4 and 6 are same side interior angles. And same side interior angles are supplementary. So angle 3 plus angle 5 equals 180 degrees, and angle 4 plus angle 6 equals 180 degrees. We can use this to solve problems. If I look at this problem here, I know that the missing angle is 45 degrees because 180 minus 135 is 45 degrees. Final kind of angle pair we're going to talk about is same side exterior angles. Those are two angles that lie outside parallel lines on the same side of the transversal. So they're on the outside of parallel lines, and they're on the same side of the transversal. So for example, 2 and 8, or 1 and 7. And these are supplementary angles. So 2 and 8 have a sum of 180, and the measure of angle 1 and the measure of angle 7 together make 180 degrees. So if we're trying to solve this problem, these are same side exterior angles. If I'm trying to figure out the value of this missing angle, the answer is it is 60 degrees, because 180 minus 120 is 60. Here are my suggestions to try to save those brain cells, because we've gone through an awful lot of stuff, and some of it is just illustrative, and some of it you're really going to need to remember. So don't memorize which relationships are congruent and which are supplementary. Don't say alternate interior angles are this, but alternate exterior angles are that. Instead, simply remember that there are only two possible kinds of relationships. They're either congruent, that is, the measures are the same, or they're supplementary, that is, the measures add up to 180. Then, when you draw a diagram, make sure that the diagram is very skewed so it's easy to see what's equal and what's not. And if they're not equal, then they add up to 180. So if I look at this example here, and I look at angle 1 and angle 5, for example, they're both obviously less than 90 degrees. They're both pretty small angles, so they must be the same. They happen to be corresponding angles, but in terms of their measures, I know 1 and 5 are the same because they're both very acute angles. As opposed to if I look at 1 and 8, I'd look at those, and 1 is obviously an acute angle, and 8 is obviously an obtuse angle. So together, they must be supplementary because they're not the same, and if they're not the same, then they must be supplementary because those are the only two possibilities, to be congruent or supplementary. Now let's use all we've learned to go through three types of problems that you're going to need to learn how to do. The first is the easiest one, which is just to find an angle measure. Now when I look at that example right there, I can see that one of those angles, as I said before, is bigger than 90 degrees, or obtuse. That's the one we're trying to find. And the one that's given to us is obviously less than 90 degrees because it tells us it's 75. So I know that if they're not the same, they must add up to 180. So 75 plus x equals 180. Now we just have some very basic algebra to do. Subtract 75 from both sides, and my answer is that that angle is 105 degrees. Let's do a different kind of problem where this one, there actually is a little more algebra to do because in the measure of the angle that's given, they have an x, and they're asking us to solve for that variable. So when I look at these two angles, I can see that they're both formed by two parallel lines cut by a transversal. There happens to be a fourth line, I should say, or actually there's a ray going off to the left there, but that doesn't matter. You can add as many lines as you want, or rays, but there are still two parallel lines being cut by a transversal. And both of those angles are acute angles. So if they're both acute, then they're the same. They're congruent angles. So I can set them equal to each other. X plus 65 equals 55. Subtract 65 from both sides, and I get that x is negative 10. The final problem is similar to the other two in that it's asking me for what the angle measure is, but it is doing it in an algebraic way, so I have to solve for x. And so it's asking me to find the value of the angle in bold. Not exactly easy to see there, but that angle in bold is the one that is 27x plus 2. When I look at these two angles, I can see that they're both obtuse angles. They're both greater than 90 degrees. And if that's the case, then they must be equal to each other. So 27x plus 2 equals 26x plus 6. To solve for x, if I subtract 26 from both sides, I end up with x plus 2 equals 6. Subtract 2 from both sides, and I end up with x equals 4. But again, the problem is not asking me for x, it's asking me to find the value of the angle in bold, which is 27x plus 2. So using substitution, I'm substituting in my value of x for 4x. So I have 27 times 4 plus 2. 27 times 4 is 108, and 108 plus 2 is 110. So that angle in bold there is 110 degrees.